Picture a Fortune 500 chief technology officer sitting in an office in Chicago. They have a $50 million cloud computing budget, an executive mandate to integrate artificial intelligence across every single product line, and 50 open headcount requisitions for data professionals.
And they are completely paralyzed.
Exactly. They cannot deploy their capital because they cannot find the talent.
Right.
Now, simultaneously, open up Reddit or LinkedIn or any major developer forum right now in 2026. You will see tens of thousands of entry-level data scientists and analysts in a state of absolute existential panic.
They're posting screenshots of their 500th job rejection.
Screaming into the void that AI has destroyed the entry-level job market, that the entry-level data role is just dead, and there's no future for new talent.
It's really the defining structural contradiction of the 2026 global economy. We're watching this massive perceived oversupply of talent colliding with an actual catastrophic talent drought at the enterprise level.
And both sides feel like they are losing.
Both sides are losing because someone is fundamentally misunderstanding the reality of the board.
And that is exactly the mission of this deep dive. We are going to completely bypass the social media hysteria today and analyze the grounded mechanical reality of the AI and data science labor market.
Because you really have to.
Yeah, for you listening, whether you're trying to break into this field, survive in it, or hire for it, navigating this landscape requires decoding what global industries are actually structurally prioritizing, not what, influencers are panicking about. We need to dissect why this disconnect exists. So let's just get right to the core of it. If corporations are desperate to hire, why is the prevailing public narrative that the sky is falling?
Because the public narrative is misinterpreting an evolution as an extinction event. I mean, the death of the data science role is a myth.
Right.
But the complete ruthless paradigm shift of what a data professional actually does that is undeniable reality. What we're witnessing right now is the violent end of the historian era of data science.
The historian era, meaning looking backward?
Exactly that. If you look at the industry baseline just, 5 or 6 years ago, the primary function of a massive percentage of data professionals was static reporting.
Just pulling numbers.
Right. You queried a database, you pulled the results into Excel or some standard BI tool, and you built a dashboard. Your entire job was to act as an archivist.
So management could look at a pie chart and feel informed.
Yeah, you summarize what had already happened in the previous quarter. But the dashboard...
They didn't actually execute anything. They just sat there on a screen.
Right. They were descriptive, not predictive, and certainly not prescriptive.
Right.
But look at the 2026 reality. Modern companies have zero margin for retrospective analysis.
Zero.
They don't want a professional who merely visualizes the past. They demand an architect who predicts the future and automates the response.
That's a massive leap in expectations.
It's the whole ballgame. The expectation now is that you don't just show them the data. You understand the underlying mathematical patterns, you actively apply machine learning to forecast outcomes, and critically...
They integrate AI.
Yes. You natively integrate AI and large language models into the actual daily workflow of the business. The job has transitioned from historical reporting to predictive architecture.
Okay, if the baseline requirement has leaped from building a dashboard to architecting predictive pipelines, that implies a massive reshuffling of the hierarchy.
Oh, absolutely.
Who is surviving this? Let's talk about the fallout, because for the last decade, the universal advice was, learn Python and you're guaranteed a 6-figure salary. Is that era just over?
It is entirely over. The professionals being structurally left behind right now are the ones who treat basic Python and standard machine learning syntax as their primary competitive advantage.
They think it's enough to just write the code.
They believe that because they can write a for loop or import a regression model from a library, the market somehow owes them a premium salary.
But wait, let me push back on that. Python is still, the dominant language of AI. Why wouldn't knowing the dominant language be a massive advantage?
Because the syntax has been commoditized. Knowing Python in 2026 is, it's like knowing how to use a keyboard.
It's just expected.
It is a baseline mechanical requirement to even enter the room. If I'm hiring you, I do not care that you know the syntax, because my AI coding assistants know the syntax perfectly.
Right. They can write the boilerplate instantly.
Exactly. I care about your applied logic. The winners in this new environment are the candidates who demonstrate applied systemic problem solving.
What does that actually look like in practice?
It means looking at a highly unstructured, messy business problem, framing it mathematically, building a robust architecture, and actually deploying that solution into a live environment. The winners are builders, not typists.
Let me stop you there because this impacts the bottom of the ladder so aggressively. There is a deeply entrenched narrative right now that freshers graduates with zero commercial experience are completely locked out.
Yeah, I see that everywhere.
The logic goes that because AI coding assistants can handle all the boilerplate code, senior developers are suddenly 10 times more productive, meaning companies simply don't need to hire juniors anymore. Is that logic fundamentally flawed?
It is heavily flawed because it assumes the definition of junior work hasn't changed. People assume that because AI automates the lowest level tasks, the entry-level job just disappears.
When in reality,
In reality, the entry-level job just move one rung up the abstraction ladder. The structural reality is that there are thousands of open roles globally for new talent right now.
but they're not hiring them to do basic tasks anymore.
No, hiring managers are not hiring you to spend 6 months learning how to write basic SQLs. They are ruthlessly selective.
Because they expect you to arrive already operating at that higher level of abstraction.
Yes, the hiring model has completely flipped from evaluating potential to demanding proof.
Potential to proof, that's a huge shift.
It is. 5 years ago, a company would look at a smart graduate from a good university and say, well, they have the potential to learn our systems. Today, they look at your GitHub repository to see the systems you have already built.
So the portfolio is everything.
It is the only thing that matters. They favor candidates with real implementation skills, a portfolio of complex projects, and deep familiarity with the AI ecosystem. If your resume just says Python and team player, the algorithmic screeners will bin you immediately.
Right.
But if your resume links to a live, deployed machine learning model that you built to solve a real-world data problem, the door's open.
This shift from potential to proof brings up a fascinating secondary effect. If what you can do matters infinitely more than your potential or your resume fluff, then doesn't that destabilize the traditional power centers of the tech world?
It shatters them.
Because if I can prove my capability through a GitHub link, why does it matter what city I am sitting in?
It matters less now than at any point in modern economic history. We are watching the aggressive decentralization of global tech power.
Let's look at India as the prime case study for this, because it serves as the massive engine for the global IT economy. Historically, tech capital and opportunity in India were fiercely geofenced, right?
Absolutely.
Oh.
If you wanted a serious career, you had to migrate to specific coordinates. Bangalore, Hyderabad, Pune, Gurgaon. The infrastructure, the companies, and the networking were locked in those Tier 1 hubs.
You had to physically move your body to the capital to access the capital. But remote work infrastructure fundamentally broke that requirement, didn't it?
Well, remote work broke the physical requirement, but the shift to portfolio-based hiring broke the cultural requirement.
That makes sense.
Yeah, when an employer only cares about the complexity of the deployed model in your portfolio, they stop caring about your zip code. Because of this, we are tracking an incredible surge in highly competitive talent emerging from Tier 2 and Tier 3 cities in India right now.
We're talking about places like Indore, Jaipur, Bhopal, Lucknow. What does that look like mechanically, though? How does a kid in Bhopal suddenly compete with a senior engineer in Bangalore or, frankly, San Francisco?
Because the great equalizer is cloud compute and open source models.
Right.
10 years ago, the engineer in San Francisco had access to better on-premise hardware and proprietary corporate knowledge. Today, a candidate in Indore has fiber optic internet, access to the exact same AWS cloud infrastructure, and the exact same open source LLM waits on Hugging Face.
So they have the exact same raw materials.
Exactly. When they sit down to build a predictive architecture, the playing field is terrifyingly level. The geographic premium has been entirely superseded by skill readiness.
That is a profound restructuring of economic mobility. Capability actively outranks geography. But doesn't this also threaten the other great gatekeeper of tech? The elite university pedigree.
Yeah, it doesn't just threaten it, it actively dismantles it. For generations, the institution you attended dictated your trajectory.
Right. In India, the IITs were the undisputed arbiters of elite status. In the US, it was Stanford or MIT.
Yeah, and the institutional degree was used by recruiters as a proxy for intelligence and grit.
Because the logic was, I don't have time to test if this person is smart, but Stanford tested them, so I'll trust Stanford's filter.
Precisely. The degree was a proxy metric. But in 2026, tech companies no longer need to rely on proxies because they have direct measurement tools.
The portfolio again.
Your GitHub history, your Kaggle ranking, your live web applications. These are direct, unforgeable measurements of your competence. The primary question from employers has shifted from, Which elite college are you from? To show me the most complex system you have successfully engineered.
So a flawless project portfolio from an unknown university will actually beat a mediocre portfolio from an elite institution.
9 times out of 10. Now, to be entirely realistic, on-campus placement at top-tier universities still provide a logistical advantage.
They get you the interview.
Right, it guarantees you a seat at the table. But in the massive off-campus global hiring market, the process is purely meritocratic and ruthlessly portfolio-driven. Your capital's your code, not your crest.
Okay, so if companies are desperately hunting for this exact type of proven portfolio-backed talent, where is the money actually flowing? Which specific sectors are driving this insatiable demand? Because it can't just be the Silicon Valley tech giants anymore.
It's definitely not. The demand has permeated the foundational infrastructure of the entire global economy. IT services and consulting are obviously still massive drivers,
Sure.
but the most aggressive hiring is happening in product companies. BFSI, that's banking, financial services, and insurance, along with telecom, healthcare, and dedicated analytics firms.
I want to double-click on finance and healthcare for a second.
Right.
Why are those two sectors so desperate for predictive architects right now?
Because in those sectors, latency and predictive accuracy are quite literally matters of life, death, and billions of dollars.
Wow.
I mean, think about a modern bank in 2026. It is no longer a vault holding cash, right? It is a massive data pipeline running real-time machine learning inference.
So they're analyzing every swipe as it happens.
Yes, they need models that can detect anomalous transaction patterns and block fraud in milliseconds. They need quantitative algorithms optimizing trades based on unstructured geopolitical text data.
And what about healthcare?
Healthcare is undergoing a full multimodal AI revolution. Hospitals are deploying systems that simultaneously analyze structured patient data, unstructured doctor's notes, and massive image files like MRIs
To do what exactly?
to predict patient deterioration before human nurses can even spot the symptoms. Furthermore, optimizing supply chain logistics for pharmaceuticals requires immense predictive power.
So they don't want historical reporting either.
Not at all. These industries do not need someone to tally up last month's outcomes. They need architects who can build engines that dictate tomorrow's operations.
The stakes you're describing are massive, which validates exactly why we do these deep dives. We aren't just talking about software updates here. We are tracking the fundamental rewiring of human infrastructure.
It really is a complete rewiring.
Right. Yeah, and if you are listening and finding this breakdown of global talent, decentralization, and sector-specific power shifts valuable, please take a second to like this deep dive on whatever platform you're using. It is the single best way to support serious, long-form documentary-style analysis that cuts through the algorithmic noise.
Because understanding these macroeconomic shifts is the mandatory prerequisite before you start optimizing the micro details of your own career.
Well, let's transition into those micro details right now. We have established the macro reality. The old historian resume is dead, geographic borders are dissolving, the elite pedigree is failing, and industries are desperate.
Right.
So if I am a listener standing in the middle of this landscape wanting to become the talent that Fortune 500 CTO is searching for, what does the actual architecture of a 2026 data professional look like? Let's break down the tech stack of the human being.
We mapped the 2026 capability architecture into 3 distinct non-negotiable layers. If your skill set is missing any one of these 3 layers, structural failure in the job market is highly probable.
Okay, let's start at the bedrock. Layer 1. The foundation. This is the evolution past the dashboard. What does it actually consist of?
The foundational layer is deep proficiency in Python, advanced SQL, applied statistics, and rigorous data cleaning and analysis.
Now, I have to interject here, because if a listener has been following the industry for the last 5 years, they're going to say, well, that is the exact same requirement list from 2020. How is that a 2026 evolution?
It's a fair question. The syntax and the tools are similar, but the commercial objective has violently shifted. Let's look at visualization.
Okay.
Tools like Power BI, Tableau, and Python libraries are still heavily utilized. But here is a critical shift in executive tolerance. Companies are utterly exhausted by fancy dashboards.
Exhausted? Why? I mean, a good dashboard makes executives feel like they have a control room.
It gives them the illusion of control. But a dashboard that merely visualizes a drop in revenue without isolating the mathematical cause or prescribing an automated intervention is functionally useless.
It just tells them they're losing money.
Exactly. It induces decision fatigue. Executives are tired of paying massive salaries to professionals who just point out that a fire is happening.
So what's the alternative?
Layer 1 is no longer about visualization, it is about extraction. The structural requirement is the ability to extract highly complex, actionable insights. If your SQL pipeline and your statistical analysis don't culminate in a direct, mathematically backed recommendation that either saves capital or generates it, your foundation is viewed as weak.
Okay, so layer one is the analytical bedrock, translating raw data into an actionable business lever. What happens in layer two?
Layer 2 is the machine learning lifecycle. But specifically, it is mastery of the unglamorous, brutal reality of that lifecycle.
I love that framing, the unglamorous reality, because machine learning is constantly pitched to the public as this magical, sentient black box that just automatically solves problems.
When that marketing has ruined a lot of junior developers, most candidates only ever learn this sterile academic theory.
Like,
Like, they understand the conceptual difference between regression, classification, and clustering. They can evaluate a model's accuracy on a pristine, pre-cleaned academic data set. They can pass a multiple-choice interview.
but that's not what the job actually is.
Not at all. The market does not pay for academic theory. The market pays for the ability to survive the friction of the real world.
Walk me through that friction. Where is the actual highly compensated value generated in layer two?
The hardest work happens in feature engineering. Think of the machine learning model as a highly intelligent but extremely literal alien entity. It cannot understand human chaos.
It just sees numbers.
Right. It cannot read a messy spreadsheet with missing values and mismatched timestamps. Feature engineering is the painstaking process of translating human business logic into structured mathematical vectors that the alien can actually process.
So you are building the translation layer between reality and the algorithm?
Precisely. But even after you engineer the features, train the model, and validate it.
There's more.
Oh, the ultimate separator. The skill that dictates whether you are hired or ignored is deployment.
Deployment. Taking the model off your local laptop and integrating it into the live company infrastructure. Why is that so highly valued? Is it just a networking problem?
It is an engineering nightmare. Academic models don't have to deal with latency, concurrent user requests, or model drift.
Let's define model drift, because that sounds critical.
It is. A predictive model trained on consumer behavior in January might be entirely broken by March because a geopolitical event shifted how people spend money.
Like inflation spikes, and suddenly the old patterns are useless.
Exactly. The baseline reality changed. If you only know how to train a model, you are useless. You must know how to deploy it via containerization, monitor it in a live production environment, and build automated retraining pipelines when the model inevitably begins to decay.
Wow, so if you can build a brilliant predictive model on your local machine, but you cannot expose it to live customer data via an API, the commercial value of that model is literally zero.
It's exactly zero. Layer 2 mastery means you own the pipeline from raw ingestion to live production serving.
Which brings us to the apex of the architecture, layer 3.
Layer 3 is AI exposure. This is the modern mandate. It is the definitive 2026 separator between a standard data engineer and a highly coveted predictive architect.
This is the layer that is causing all the panic on the forums right now.
Yes, but the panic is entirely misplaced energy. This layer is about integrating generative and advanced AI into your pipelines. It requires deep familiarity with large language models.
Beyond just chatting with them, obviously.
Right. It requires mastery of prompt engineering. And to be clear, I do not mean typing clever questions into a ChatGPT interface. I mean programmatic, system-level prompting where you chain prompts together inside a Python script to force the AI to execute complex reasoning tasks autonomously.
You also mentioned vector databases earlier. Why are those suddenly the hottest infrastructural requirement in the industry? Why weren't we using them heavily 3 years ago?
Because traditional databases, like SQL, search for exact keyword matches. They look for specific strings of text. But an LLM doesn't understand keywords, it understands semantic meaning.
So how does a vector database fix that?
A vector database takes words, documents, or even images, and plots them as coordinates in a massive, multidimensional mathematical space. Concepts that are similar are clustered closer together in that space.
Like, if I search for puppy, it knows to look near golden retriever even if the words don't match.
Exactly. This allows an AI to search for meaning rather than just keywords. It is the architectural mechanism that gives an AI long-term memory and contextual awareness. If you cannot build a retrieval-augmented generation system using a vector database, you cannot build a modern AI application.
If we look at the tooling for this three-layer stack, what specifically is the industry standard today?
You must be natively fluent in the modern ecosystem. We are moving past the foundations of pandas and scikit-learn. The heavy integration requires mastery of frameworks like PyTorch and TensorFlow for deep learning and intimate familiarity with Hugging Face.
Why is Hugging Face so critical? Why not just use proprietary models from the massive tech giants?
Because enterprise companies are increasingly terrified of sending their proprietary, highly sensitive data to a closed-source API controlled by a third party.
That makes sense. They don't want their customer data training someone else's model.
Exactly. Hugging Face is the nexus of open-source AI. It allows a data architect to pull a highly capable open-source model, download the weights, and run it locally on the company's own secure servers.
Complete data sovereignty.
Yes. And layering over all of this is cloud infrastructure. Basic exposure to AWS, Azure, or Google Cloud Platform is no longer an optional bonus. Recruiters monitor it as a strong signal of readiness.
Because it proves you understand where these massive models actually live, scale, and compute. When you lay the architecture out like this, layer 1, deep statistical extraction; layer 2, full lifecycle ML deployment and monitoring; layer 3, advanced element integration and vector memory, it makes me realize something quite disturbing about the education market. This 3-layer requirement completely obliterates the short course bootcamp industry.
It mathematically destroys their entire business model.
For the last decade, we have been inundated with advertisements for 6-week boot camps promising a seamless transition to a 6-figure tech salary. Learn data science in 30 days. But what you're describing, you just can't learn that in 30 days.
It is cognitively impossible. You cannot compress the mastery of statistical foundations, feature engineering, containerized deployment, and vector mathematics into a few weeks of evening classes.
It's just too vast.
It requires deep, sustained, outcome-driven struggle. And corporate hiring managers know this. When they look at a resume that relies solely on a single 6-week certificate, they immediately recognize that the candidate possesses only surface-level syntax knowledge.
They lack the structural depth required to survive a 2026 production environment.
Exactly. It is the equivalent of taking a weekend CPR course and then applying for a job as a cardiovascular surgeon.
The scale of the problem fundamentally rejects the level of preparation. So let's provide the antidote to that. This is the moment to push you for highly actionable, aggressive intelligence.
Let's do it.
If a listener is standing at ground zero today, perhaps they are transitioning careers, maybe they are that developer in a tier 2 city feeling isolated, or maybe they just realize their current skill set is dangerously outdated and they are facing this intimidating 3-layer architecture. What is the exact mechanical strategy to survive and conquer the next 12 months?
If you are starting today, you must implement a ruthless, highly disciplined 6 to 12-month survival roadmap. We break this down into a precise 4-phase blueprint.
Let's execute phase 1.
Phase 1 is the foundation phase, and the most critical rule here is restraint. Yes. You do not touch the shiny AI tools. You do not look at LLMs. You spend this phase mastering the unsexy bedrock. You build rigorous SQL querying practices. You learn to handle missing data in Python without just deleting the rows. You internalize applied statistics.
You're forcing yourself to do the hard work first.
Exactly. And you build your first strong analytical projects where the only goal is to extract a hidden business insight from a chaotic data set.
So you are building the cognitive muscle to look at numbers and see behavior. How long does phase 1 actually last?
Depending on your prior mathematical background, 1 to 3 months of intense daily focus. Once you can reliably translate raw data into business logic, you immediately transition to phase 2.
Which is specialization. And this seems to be where the majority of self-taught developers get lost in the woods. They try to learn every single framework simultaneously.
Yes, it's the classic trap of tooling bloat. They suffer from technological FOMO, the fear of missing out. They try to learn AWS, Azure, PyTorch, React, and data engineering all at once, and they master absolutely nothing.
So how do you avoid that in phase 2?
In phase 2, you must make a strategic, vital choice. You have to choose a specific lane. Are you going to focus on data analytics? Are you aiming for full-stack data science? Are you specializing strictly in machine learning operations? Or are you dedicating yourself entirely to Gen AI applications?
Why is choosing a lane so non-negotiable?
Because the modern tooling ecosystem is simply too vast for a generalist to be dangerous. Once you choose your niche, you spend phase 2 building highly complex structured projects explicitly within that domain.
Give me an example of what that portfolio looks like.
If you chose machine learning, your portfolio should demonstrate end-to-end deployed models with active monitoring. If you chose analytics, you are solving complex supply chain optimization problems. You must become lethal in one specific area rather than mediocre in five.
Okay, phase one is foundation, phase two is specialization. The listener now possesses the actual capability, but they still don't have the job. The capability is invisible to the market. So what is phase three?
Phase 3 is exposure. This is the mechanism of building undeniable credibility. This is where you rip off the Band-Aid and expose yourself to the brutal reality of the public market.
How exactly do you do that? What is the mechanism for public exposure?
You participate in open warfare, you apply for competitive internships, you enter grueling 48-hour hackathons, you compete in Kaggle data science competitions, and you make active code contributions to open source repositories.
Why is this so vital? Is it just for networking?
No, it is about submitting your intellect to public scrutiny. You cannot hide in your bedroom writing isolated code forever. Participating in a Kaggle competition proves to a hiring manager that you can handle real, messy, adversarial data sets under a time constraint.
It's an undeniable signal.
Right. Having your code merged into a public open source project proves that you can collaborate with senior engineers, that you document your work, and that your logic holds up under peer review.
It is the ultimate proof of work. It is the portfolio generation engine that completely replaces the need for an elite college degree.
Exactly. Which brings us to the final tactical execution. Phase 4. Placement readiness.
The actual hunt for the contract.
Yes. This is where you translate the capability into capital. This involves aggressive resume positioning. It requires hyper-specific LinkedIn optimization.
What does that mean, hyperspecific?
It means ensuring that the structural keywords we discussed today, terms like vector databases, model drift, and end-to-end deployment, are naturally embedded in your project descriptions, so you pass the algorithmic screeners. You submit targeted applications, but more importantly, you leverage the network you built in Phase 3 to secure professional referrals.
Because an internal referral completely bypasses the HR algorithm.
Always. A referral drops your resume directly on the desk of the technical hiring manager. But remember, a senior engineer will only refer you if Phase 3, your public proof of work, is flawless. They are risking their own reputation to recommend you.
This four-phase roadmap is incredibly intense. It requires an immense amount of isolation, discipline, and sustained cognitive load. And it strikes me that the ultimate hurdle for the listener right now isn't necessarily intellectual or technical. The defining barrier is entirely psychological.
It is a profound psychological filter. The mental model a candidate adopts will literally dictate whether they survive this transition or get washed out.
I want to break down those mental models. What does the psychological profile of failure look like today?
The candidate destined to fail maintains what we call a job requesting mindset.
Job requesting. Explain the behavioral traits of that mindset.
The job requester operates from a position of profound insecurity. They believe the market is totally saturated. They desperately hope that completing a superficial 30-day course will somehow entitle them to a high salary.
They're waiting to be picked.
Exactly. And most dangerously, they approach employers from a position of begging for an opportunity. They view themselves as an unproven commodity and ask the company to take a massive financial risk on them.
Their entire posture is, please hire me. I promise I am a fast learner. I will figure it out on your dime.
Yes. And in 2026, corporate margins are too thin and the technological complexity is too high for any company to take that risk. They do not have the time to be your training wheels.
So what is the exact opposite? What is the optimal, realistic mindset that guarantees placement?
The successful candidate undergoes a radical shift to a capability-presenting mindset.
Capability presenting. That framing immediately implies leverage.
It is the ultimate leverage. This candidate understands the macro reality. Despite all the social media noise about AI taking jobs, a massive, crippling skill gap still exists at the enterprise level.
So how do they approach the interview?
Because they have spent 12 months mastering the foundations and building a public portfolio, they do not ask for a job. They present a solution to a bleeding corporate wound.
They aren't saying, hire me. They are saying, I noticed your e-commerce platform is losing 4% of revenue to cart abandonment. I built and deployed a predictive churn model on my GitHub that identifies those users in real time. Here is how we implement it.
Precisely. They focus entirely on the business's pain points. They understand that true capability inevitably leads to placement, and that proven placement naturally dictates high compensation. When you approach a CTO with a deployed solution rather than a pre for training, the power dynamic of the interview completely flips.
If you bring the capability, the leverage shifts entirely to you. You are no longer asking for a favor. You are offering structural support to an executive who is desperate for it. That reframing is incredible. It takes all the